while you're doing that, I'll just thank you all for inviting me. It is a privilege to come down and share with you all personally what we've been working on for really the last 8 years in fisheries. Some of the work is kind of carried over from previous studies that we were involved and engaged with when we were working in a water quality group. But about 8 years ago, fisheries made the decision that they would develop or create a habitat program. And what the director at that time kind of pulled people from different areas of the department who had been working with water quality fish habitat relationships, and that's Howard engaged me and my present boss Jim Uphoff, who I think is probably the mastermind behind understanding water quality fish habitat responses in a broader ecosystem context. And so what I'm going to show you all tonight is a lot of the science, briefly the science behind what we've been doing, and then a couple slides at the end to really show you how we're trying to translate this science into management action. And I'll preface this, and I'll probably come back to this point in the talk, that one of the things that we have understood, and it wasn't a surprise to us, but as we've engaged into looking at these landscape interactions, we've realized that we have to be a lot more aggressive than traditionally we have been in communicating this information beyond just our normal constituents, which are fishermen, commercial and recreational fishermen. And so when we initiated the project, we were thinking mostly that we just look at how we can better manage fisheries, but we're realizing now to manage fisheries, we need to manage landscapes. And so kind of our selling point, our tagline, or whatever they call it, our Twitter, or tweet, is land management is fish management. And that's the selling point, or the bumper sticker that we've been promoting. What we're looking at this year, really developing, is even more of a targeted message, because we're understanding that a lot of the rural landscapes are under threat. And we're really seeing the importance of hanging on to farmland, even though farmland has some challenges. But we're also thinking about promoting this healthy farms is healthy fish, healthy farms is healthy fish. So a couple different tweets that we want to put in everybody's mind to kind of plant this idea that we do need to be more invested in landscape management if we're going to have healthy fisheries for the future, productive and sustainable healthy fisheries for the future. So if you get nothing else out of the talk, that's what you can take home with you tonight. And I'll show you the science behind why we're promoting this message. But as you can see, our program is pretty small, but we're very ambitious. And we've done what we can with limited resources to develop some studies to really examine this linkage between landscape and fish habitat. As I said in the intro, we started out with just a focus on trying to understand what is happening with fish habitat, how is that affecting fish production, and how can we improve our fish assessments with that understanding. As we've evolved and as we've come to develop more studies and and looked at and evaluated more of our results, we're realizing, as I said, that we need to start communicating and interacting, partnering really with land managers, planning agencies at the state level, but also at the local level. And then also at the same time, really promoting public support for watershed conservation. And I know you are hugely invested in that, and feel free to stop me anytime and ask questions. But I support your efforts because what you're doing is trying to really save fish habitat in the long run. Now, our work began with just a single focus study that evolved from some work that had begun in 1989, and over the last 8 years or so, we've developed multiple studies looking at various species and also various life stages of these species. And one thing you'll see in this picture in the middle, if you're familiar with fish species, these are really all common species that we manage. Common species are the ones the public like because they're abundant and typically easy to catch. That changes, as some of you all know. One of the first studies that really launched this project was looking at summer juvenile assemblages. The fish that are present in the summer, generally small, first year, born in the spring fish. And we did some pretty rudimentary sampling, seine and trawl, fun, but not easy, but fun, and comprehensive sampling using seines and trawls in the summer, and tributaries looking at impervious cover, tributaries with low impervious cover to very high impervious cover. Impervious cover is our stressor variable, but it's an indication of the amount of development in the landscape. And so we targeted that as our stressor variable, understanding that it does reflect the condition of the landscape.
Now, the number we keep hearing is that above 10%, it's critical or getting really bad. Are you still with that number? Fisheries?
10% is what I'll show you.
10% impervious cover.
10% impervious cover is kind of the threshold where you go from the ability to manage with some limitation to a different regime. And so, but I'll talk about that at the end. We have different thresholds and gradients that we're applying for different management actions. But you know, the first step was to just kind of get an idea of, is impervious cover, is it development really a stressor to fish and fish habitat? And we looked at tributaries that were low in salinity or moderate in salinity, and then we have some tributaries that are low, what we call tidal fresh, so very low to no salinity at all. And it's important to note that, because we did find a difference in what we were seeing in terms of response to impervious cover. And so one of the first things we looked at is oxygen. Oxygen is critical to anything, and of course it's critical to fish. And what we did find in the deeper waters, and when I say deep, I'm talking about, you know, maybe 10 feet of water down to 6 feet of water. So deep in terms of small tributaries, but not deep in terms of the Chesapeake Bay. So what we found is, as impervious cover, as the impervious cover development increases in these higher salinity waters, you get a decline in oxygen. And what I want you all to note, I meant to bring a pointer, but if you look at where that 5% is on the graphic, and you draw a line up, and then take the 5 milligram per liter, and you draw a line over, and they intersect, you'll see a lot of the readings fall below 5 milligrams per liter. 5 milligrams per liter is the criteria, the Bay Program criteria for suitable for fish. So what that says to you is that once you get to 5% impervious cover, you have some violations of habitat DO criteria for fish. If you wanted to, using this information, if you wanted to set a criteria that would assure that you're meeting your 5 milligrams per liter criteria all the time, you would set that more at 3% impervious surface, which kind of coincides with some of the freshwater information that comes out. 3% is a threshold for trout, actually 2% for trout, 3% for some of the cold water species. And so it is interesting that you see a water quality criteria response at that level. Now, the interesting thing that puzzled us when we first started looking at this is we didn't see the same oxygen response in the tidal fresh waters, the low salinity waters. What we believe is going on in these higher salinity waters, anytime you get salinity, you get stratification and you get a salt wedge, and so your circulation patterns change. And so in these higher salinity waters, you're not getting the exchange of water, and the effects of development that are forcing oxygen down are pronounced in these areas because you're not getting tidal flushing, the water's not exchanging and being reoxygenated. So in areas where you have salinity in high urban areas, we expect to see greater violation of oxygen criteria. So poor habitat for fish. And what we've seen, and I didn't bring a graphic to show this, but what we have seen in some of the urban tributaries around Annapolis, like the Severn River, South River, and Magothy River, is basically a habitat squeeze. All the offshore deeper water oxygen is gone, and in the summertime that can actually be almost water column wide. And so it forces all the fish near shore into shallow waters. Well, if you've got species that are being eaten that naturally go into the shallow waters to hide from predators, trying to hide out there, and then you've got predators being forced in because of oxygen conditions. You can imagine that there's more predator-prey interaction. And so we don't quite know what's going on, but you know, basic fish ecology suggests that that's problematic if you're a species trying to survive, you know, from being eaten. So, was there a question?
What runs the Chesapeake Bay?
Pardon me?
What runs the Chesapeake Bay? I mean, we have been pulling the seines down at Port Tobacco River for years. We get thousands and thousands of fish. We put a plankton net out there, we don't get. So what are these fish feeding on?
Well, that's a good question. Actually, another study that we've been kind of involved with, and I'll show you this from some of the larval work that we've done, looking at some of our more resident type species. But there is some work being done on the trophic balance of the Chesapeake. And as you all know, if you've read the papers and followed the Menhaden story, you know, there seems to be more and more pressure on the forage species. And, you know, the question, what runs the Chesapeake, is a big question because we don't have a lot of good phytoplankton data to be able to develop these trophic models to understand what's going on. I mean, there's some indication that some of the primary production could be shifting to bacteria. And if that's the case, then you've got a less productive food web for some of the other species. In other words, it takes more energy, and fish have to expend more energy to eat. And so there could be this kind of precarious balance right now that we're looking at. But I don't know. I mean, those are some thoughts that we've had. Those are some discussions. But one of the things that you all can do is be a voice. I should turn the mic off at this point, but it's okay. One of the things that we want to push for at the Bay, for the Bay program is we really believe that someone needs to develop a good ecological model for the present state of the Bay, so that we can understand what is the ecosystem today. We know it's not like it was when Captain John Smith came. We know it's not like it was 50 years ago. What is the state of the Bay? What is driving the production? And then how are our management goals feasible in the context of that ecosystem? That's really the question that I think needs to be answered. But it's a tough question, and it's expensive to throw money at that question. But if we hope to really maintain production at a certain level, we need to understand what is, you know, supporting that production. So that was a great question. Unfortunately, I don't have a good answer for it. But what we can tell you is some of the impacts that we're seeing from land development, and that's our concern, because we know that you know, as Maryland progresses, everybody's turning to houses as the revenue generator, and that may not be the best answer, as we can see, or there are going to be costs, I should say, to that kind of management approach, or revenue generating approach. So we saw this decline in oxygen in the high salinity waters. We didn't see the same thing in the low salinity waters. In the high salinity waters, as you would expect, as oxygen declines, fish decline as well. Now the key to this is these are, you know, in blue crabs too, which was a little interesting for us to see. We didn't think that blue crab would respond too much to these low oxygens, because they're pretty good at avoiding. But we see that as your impervious surface or development in a watershed increases, you have less of a chance of seeing these species. That translates to less opportunity for fishermen. And, you know, if you're a fisherman, you should be concerned about that. Even if you're not a fisherman, you should be concerned about that, because it's less production for the Bay. Another thing that we saw, this is work that came out of CERC, Ryan King and in his group. They were looking at fish consumption advisories, and they did find this increased advisory, or increased PCB levels in fish in relation to an urban gradient. And of course PCBs have been banned forever, yet they're persistent, and they suspect that as land is being disrupted, you're mobilizing PCBs, they're getting into the food web, and of course that means that, you know, there's more consumption advisories being issued for these species.
So would you say this is characteristic of most of the tributaries, or?
His work was centered around the tributaries around Annapolis. So, you know, it's representative for the areas that he sampled. I'd have to go back to his paper and look at his conclusions, but it is a concern. I mean, one thing about studying ecosystems, it's not a one-size-fits-all, but it is, you know, if you look at it from a risk assessment point of view, then these are some things that we need to be concerned about and aware of.
And when you say you're creating impervious surface, you're disturbing PCBs. They're not something that occur naturally.
No. But they're bound. They're bound,
Okay.
and so if you disturb soils, you can mobilize them. That's what they suspect is going on.
So they're already like there. Like if somebody cuts down the forest and builds a house, the PCBs are. No. Okay. So what?
Well, I guess there's sources still. I mean, there's diffuse sources because they were associated with all kinds of.
PCBs were associated with hydrocarbons, with lubricants, with paints. They're entirely
Transformers. Yeah,
transformers were a major use, but all kinds of industrial capacitors. There were a lot of uses for them involving high temperature. So it's primarily an urban area contaminant. It is bound to soil and relatively immobile in place, but acid water conditions, and more importantly, I think what you're seeing is resuspended soil.
Mm-hmm.
You disturb the site. A lot of people don't sample sites before they work on them. So actually urban renewal is a pretty good source of PCBs. You're taking down old buildings, you're taking an old industrial area, an old railroad yard, usually they're sampled, but an old industrial area and so-called brownfield, and making it into something new. That's a great way to release PCBs.
Well, and you know, the question that is, what is the legacy? I mean, where are they present? Are they in streams? And, you know, as you change hydrology, are they getting washed down? Are they coming off of runoff of construction sites? That kind of thing, you know. So
probably the sediments of every urban stream in the United States.
Yeah, I'm trying to think. I did, years ago, we collected some chem data, and I'd have to go back and look, but I know one of the things that everybody was a little shocked by, which shouldn't have been a surprise at that point, but the greatest number of chemical hits were from sediments from urban tributaries. So, and I can't remember, I don't know if they tested for PCBs. I don't know. I don't know. I guess because a lot of folks thought that some of the agrochemicals should show up, but they're pretty you know, they're not very persistent. So
the newer ones are not very persistent. Doesn't mean they're not harmful, but the older ones are much more persistent.
Yeah. Well, this is you know, this is another thing to be aware of, another concern that we have as we look at developing watersheds, you know, these concerns that we all have. Now I wanted to come back to this because, like I said, in these freshwater areas we did not see an oxygen response to increased impervious surface, but we see in Madeline, we've been sampling in there since 1989, and we have seen a collapse in the fish, in the production and actually the community there. And so this indicates that though there's not an oxygen stressor, there's something going on in that area, in that subtributary, that is causing a decline in these fish.
What months were you sampling?
July, August, and September. And this is prior to snakehead and blue cat.
So every time there is a storm event in July, August, and September, what's the temperature of the water coming off the impervious surface?
Sure, it's elevated, but we're looking down at the downstream tidal area, so a lot of that is ameliorated. It's not...
But not where the larvae are.
Well, these are juvenile. These are juvenile at this point.
But eggs, larvae, and juveniles will be strongly affected by even a degree or two in temperature.
but at this point, a lot of the species that we are looking at that have been lost out of here aren't produced upstream where you see those thermal effects. So we're seeing this decline, and it could possibly be a thermal effect. However, it is disconcerting to see this kind of change when in 1992, if you're around Jim and Bonnie long enough, you hear the famous quote, it was the most productive subestuary that we could identify in the Maryland portion of the Chesapeake. So this is a pretty alarming, and we're hoping that we see an uptick.
What was different about those years?
I mean,
if it was always that high, where some of the preceding was that high?
There's natural variation in here, but one of the things that we've shown, and I don't know if I put it in here, a graphic, but if you all go on our website, there's a number of our reports that you can look at, but we have looked at increased development in the watershed, and some of these trends that we're seeing in the fish and water quality and different measures do track that trend in development pretty tightly. So
I understand the DNR is going to put a $60,000 fish counter down at Mountain Creek.
DNR is not going to do that.
Well, somebody.
Smithsonian CERC is going
Could
to.
be.
It's they don't know yet if they're going to do that.
I'm pretty sure.
Yeah, but they're the ones that are going to do that, and actually Tuck Hines is the PI on that project. But they're looking to develop a technology where they can count herring and shad in order to help produce better numbers for the coastal stock assessment, so they can get a better handle on what's going on with those species. But now, one of the things, interestingly, you saw in the graphic that I showed previously that we didn't see oxygen violations in the deeper waters in these freshwater areas, but we did, there was a site in Mattawoman right at Smallwood Park on the end of a pier that is a continuous monitoring site, and so they collect every 15 minutes readings of different water quality parameters. We did observe that in this area, SAB began to really populate and became very dense around this meter. And when we started pulling the records, we found that there were some violations of oxygen. So at night, when the plants would begin to respire, oxygen would decline, and then in the day when they start to produce again, we'd see the oxygen return. One of the concerns we had, if you all know, Smallwood is hosts bass tournaments, national bass tournaments. And it happened to be that this area where the meter was where they were releasing all their bass. So we saw this oxygen issue, and we wanted to see how extensive it was. So 2 years ago, we worked with some of the folks, Jim and Bonnie, and some of their partners, and they did some intensive sampling in these SAB beds. That one SAB bed that's off the park and goes around the marina into that cove. And what they found is that these SAB beds have some oxygen issues associated with them. And if you see 44%, almost half the time, the bottom oxygen in these beds were below the criteria for fish. So what we suspected was good, or what's supposed to be good habitat, ends up being problematic. This happens to be hydrilla dominated, which is not a native species. And so that's part of it. And there's there's information from Florida and California that where they've really looked at the ecology of hydrilla, and they've found as an invasive, it can do just what we're seeing it do. It can cause oxygen issues and also pH issues in some cases. So, you know, water quality looks great in Mattawoman Creek. If you measure water quality according to the Bay Program criteria, it passes. But here's an issue that nobody expected. So, you know, we're wondering, okay, we can track increase in impervious, and SAB seems to follow it pretty well. So what we think is, and we also know from gauging stations that phosphorus and nitrogen loads are pretty high there, as well as sediment loads. But we think that what's going on is these plants are intercepting a lot of that nutrient, and they're doing very well. But it's also causing some problems for habitat. Is this why we're seeing the change in the fish community we're seeing? We don't know. A lot of people, you know, when we first showed our graph, a lot of the folks said, well, they're all in the SAV. And we knew from experience in sampling and the types of species there that they weren't all in SAV, because not all of them are SAV associated. So, and then when we came up with this, it showed that even if they are, it's not real suitable, and so there could be survival issues going on. So we're also looking at spawning habitat for migratory species, trying to understand how land use could be impacting spawning habitat use. We had some early indications that things were changing. There were some declines in spawning habitat occupation in areas that were highly developed. And so we recruited a bunch of volunteers in some watersheds around the state, and they repeated some of the historical survey work for us. And what we found is that indeed, as impervious surface, an indicator of development, increases, as development in the watershed increases, you see a decline in spawning habitat occupation. So here's another habitat impact that could actually affect production for fisheries.
Does each dot represent just one study, or because I see a lot of the studies in the number 10?
They represent years. Yeah, different years.
Okay.
Yes. So
does that mean in the deer?
1 year's worth of Deer Creek? Yes.
That's all. Just.
And we're repeating that.
Okay.
But there's historical data too that suggests that that point is pretty accurate. So, but you know, the state of the historical data is a little, it's not as robust as we'd like it to be, or not as high quality as we'd like it to be, but there are indications from the historical information that number's going to hold out as long as they keep that tributary intact. So
we find a lot of baby, for want of a better term, of the genus Alosa in Madeline Creek, and Madeline Creek? Yeah, where we do our seine. And we don't know what the hell they are, you know, they're just little silvery fish.
what time of year do you do that?
Fall.
Fall. How big are they? They could be, you know, they could be hickory, American, although in fall they're usually bigger. They could be gizzard shad, and they could be one of the herring species. And I could help you. I could give you some tips on how to ID those if you want.
We have a big pool and cut them open, look at the gut lining.
That's part of it. For gizzard shad, there are some external morphology you can look at, or you know, characteristics you can look at. That would keep, you know, you wouldn't have to cut it open. If you identified it was a gizzard shad, you wouldn't have to cut it open. But I could help you with that. And then
these are all about this big. They're all just plain silver. We just throw them in a bucket and say, Alosa.
That's the easiest way. It would be nice to know, though, what species they are. It would be helpful. Yes, we believe in some cases they are, depending on the year. You know, but what we've seen, I didn't throw in the graphics that have, Jim Long has done a great job looking at the historical production or in the historical condition of spawning in Mattawoman. And when we first started working with Jim, I think it was 1990, somewhere around there, we would take 5-minute samples from Mattawoman, and it would take me 2 days in a lab to sort through them. It was that many herring. Now we take the same 5-minute sample at Mattawoman, it takes not even 2 hours. So that's the loss that we're looking at, the loss in production. And you know, we're always trying to identify what is the stressor. And we happened to come across some data in Mattawoman that was available where we could actually recreate a historical baseline. And this was data on conductivity, specific conductance of the water. And you see the dotted line, the straight line, the dotted line, there's a baseline conditions from the 90s. So conductivity never went over 120 micromoles. The more recent data from 2009, I think there was a huge storm event where one of the volunteers saw pile of salt by a bridge right above a gauge, and you could actually see spikes in the gauge and conductivity. And when we went back and pulled our data, we take conductivity measurements when we collect our samples. We actually saw this elevated conductivity above baseline. What is that distressor? We don't know, but it's certainly an indication that the habitat has changed, and given that spawning occupation has declined, fish are responding to this habitat change.
Not all the salt gets flushed out, all at once. It gets in the soil and it seeps down throughout. And then as it warms up in the spring, it wouldn't take a hell of a lot of salt to impact somebody that size.
Well, that's true, and you know, there's studies. The Baltimore long-term ecological study, they've been tracing salt in groundwater, and they find it's very persistent, and they're finding groundwater signatures with elevated salt levels. So, you know, it is a concern. If conductivity is the problem, the good news is it's correctable. I mean, if that's all that's causing these habitat losses for spawning, then that's good news for us, because we can manage that. You know, I don't know if it is. I think we suspect we're kind of thinking it's probably not that simple. But anyway, another area we've been looking at is yellow perch presence. Jim Uphoff had done some work in the past looking at yellow perch presence, and he was able to develop a historical kind of baseline for yellow perch presence. It's a good, robust measure that kind of indicates how well yellow perch larvae are surviving. And we started collecting samples around representing different habitat types and different impervious covers. And what we see, I mean, this is a little bit confusing. There's a lot of spread in the data. But basically, you see forested watersheds have high prevalence of presence. And that's pretty consistent, pretty tight. There's not as much spread in that data. Agriculture can be all over the place, but once you get to an urban setting, there's a very low probability that you're going to see larval presence, which indicates that they're not surviving or being produced even. Now, we've also looked, this is where the food work comes into our study. One of the things we noticed when we were doing some of the sampling in these urban tributaries in the spring, we would pull a sample and we would look for larvae, and the sample would be clear as pool water. And so that was an indication to us, you know, in the spring, during the time when these fish are little, there should be abundant zooplankton. That's what they eat. When we saw water samples with nothing but pool water, you know, looking like pool water, we started wondering what's going on. Where is the production? No wonder we're not finding fish if there's no food here. So we started saving some of our specimens and looking at the guts. If you can imagine a fish that small trying to find a gut in the first place, but trying to find, you know, really trying to develop an index to determine how full, how well are these fish feeding. And we came up with just a very simple approach, looking at the amount of food in the gut. And what you see is there's a correlation between the amount of development and feeding success. So as development increases, feeding success declines. Now, there seems to be a relation to the amount of detritus, which is kind of the dirt material in the sample, and there's some suggestion that there could be a supply issue. We can get into that later, but anyway, there is seems to be a feeding response or a decline in feeding or food availability for these little fish. Another indicator of habitat change was really observed in the Severn River. There was a study or a group of a program where school children would take yellow perch eggs in the classroom and hatch them out, and then return the larvae to their natal stream. And one of the things, we were working with Arlington Echo on the Severn, and they were collecting eggs and turning them back into, or giving them to the schools. And they reported back to us that almost across the board in these schools, the eggs would hatch and the larvae would die 5 days post-hatch. So that indicated to us, you know, if it were one school and consistently had the problem, we could say probably a handling issue. But when it was across the board, there was something else going on. Our hatchery guys collected eggs, and the eggs on the left are from the Severin, and the eggs on the right are from the chop tank. And visually, you can see quite a difference in the condition of these egg chains. When they estimated hatch rates for these eggs, and the hatchery guys basically found that Severin hatch rates are about 10%. Historically, they had been up around 90, maybe to 100%. So there was a decline in hatch rate. In next week or the week after, Fish and Wildlife and USGS will be releasing a paper. They went in and they started looking at the reproductive condition of some of the fish. And Vicki Blazer with U.S. Geological Service did a lot of work looking at the eggs, and she has reported that the eggs are in poor condition and there could be some other issues with reproduction. So I can send you the link when it comes out. They're going to do a press release, and it should be on our website as well. But I would encourage you all to look at it, because there's indications that this is really getting beyond a habitat disruption to a reproductive issue. And you all probably heard a lot about endocrine disruptors. Well, you know, this could be a potential for endocrine disruption. The unfortunate thing with their work is they didn't have the money to be able to do the chemical analysis. They could do the histology and see the tissue, you know, the response in the eggs or the condition of the eggs, but they didn't have the money to do the chemical analysis to identify what was causing that. They still have the samples, and we're hoping to try connect them with funding somehow so that we can have a better indication of what's going on there.
Did they talk about the organic wastewater compounds at USGS that comes out of sewer systems?
Not in this study.
Cosmetics, pharmaceuticals, those types of things.
The Severin eggs look better than the chop tank eggs. The Severin would be more impacted by urban, I'll call urban contamination, than the chop tank would. The chop tank would be impacted by a lot of corn ground, which leads us to almost innumerable papers talking about herbicides.
Well, the chop tank eggs are healthy and they're hatching well, you know. Years ago, Lenwood Hall and his group over at the Y Research Center, they were looking at persistence of some of the atrazine, metallochloride, and those things. And basically, they found that they were looking at, you know, distance to the input. And it was, they couldn't find, really after a rain event, they couldn't find much of the chemical left, if any. And I think they were looking at bioavailability as well, and they didn't see a lot that indicated that they persisted. You know, we don't know what's going on with these Severin eggs. We do know that reproduction is failing there because we get no larvae. We did a ton of work in the Severin, and that study is on our website. But we stocked, you know, larval fish, tons of larval fish, and we didn't get any kind of survival. There is, interestingly, a trophy fishery in the Severin. If you want a good place to catch big yellow perch, the Severin, you probably heard, it's a good place to go. We think that those fish really represent the years where we had high flow in the bay. And what we think happened is that some of the fish from the upper bay repopulated the Severin. And you know, and so now they're growing out. If they can make it to a juvenile stage, they probably can survive. But it's getting to that point that's the problem for these Severin fish.
How many percentage of homes along the Severn are on septics? I know that
I don't know.
Harold Harbor is on septics.
Yeah.
That's where my daughter lives,
Mm-hmm.
and definitely they're on septic. So I think a lot of them are.
Probably a lot, especially a lot of the older communities.
The state has primarily talked about nitrogen. We're talking about nitrogen. Nitrogen compared to some of the other things we're talking about in terms of endocrine disruptors, nitrogen isn't even in the ballpark. It's all the other stuff that comes out of wastewater treatment plants and septic tanks that can impact a lot of this.
Mm-hmm. Well,
what kind of money were you talking about? I mean, how much money are we talking about for that study that you were saying they would like to do? And is that going to would that show the link to the disruptors? Or what would it be able to show us?
It will be able to tell us internally what the chemical situation is for the fish that's causing these abnormalities, and then maybe you'd have to talk more to Vicki and Fred Pinckney about this. But I think if they could identify that, it might take them a step closer to identifying what the external cues are. I don't know. I don't know. That's my thinking on it. I don't want to.
Scale. So, I mean, it sounds like it must be very expensive. Is there some way they could do that on a small scale?
You'd really have to talk to them. I know what we asked because we were hoping to be able to, you know, pull some money together, but it was about $100,000 they were looking for to really get these samples. I mean, anytime you talk chemical analysis, it just skyrockets. So, but you know, we're hoping that as this press release comes out, it will trigger some some response, and then they'll get some funding, you know, as a result of that.
I'm waiting for somebody to come out and say, this is all caused by big offshore trawlers targeting Atlantic herring and catching our two species as bycatch process. You don't think that's part of it?
I think the bycatch fishery has an impact, but I mean, there's definitely habitat impacts. There's definitely habitat impacts.
Sure, but I mean,
you know, in some cases, I mean, like shad, we've closed the fishery on shad. We've done everything possible we can to manage shad from a fisheries manager's point of view. And
I have great success in catching hickory shad.
Hickory shad we've never managed. Hickory shad is a southern species increasing its northern range. But you know, American shad we have a moratorium on, and we've had a moratorium forever. One of the things I can get into this in the next slide, but one of the things fisheries managers, we regulate harvest. If the population starts to decline, we limit harvest. That's our tool. So
we can't limit harvest to some Polish ship coming over and loading up on.
Yeah, you'd have to talk to the coastal stock assessors, but you know, there's a strong debate about how much is being taken in bycatch. But you know, even if we eliminate the bycatch fishery, I think we have a pretty substantial problem, and part of it's habitat, and that's the thing that's never. It's really never estimated and thrown into the assessment. That's why we started doing this work, is to try to come up with some kind of measure of loss to habitat, so we could improve our assessments and have an accounting for those losses in addition to the losses to the fishery. So, but it's difficult to estimate. It's very difficult to estimate. But you know, basically, I think you all have kind of gotten the bottom line, that there's a development issue here going on, and fish are responding to it. And so we started working with some of the land managers, trying to figure out how can we communicate this information to our fisheries managers, but also the land managers. And we came up, here's the thresholds, Jerry. Okay. We came up with the impervious thresholds that come out of the whole collective body of the work we've been doing. And so what we're doing, we translate these, or we communicate these thresholds to both land managers and fisheries managers. And what we're telling the fisheries manager is that when you have less than 5% impervious cover, you can probably manage your fishery as you normally would, by adjusting harvest levels as you see fluctuations in the population, which are natural. What we would say to the land manager is these areas are crucial to conserve. They're important habitats. We promote conservation of these watersheds, and then restoration where possible. So if there are some streams that need some rehabilitation, we would promote doing restoration in those areas first, because we believe that they're still in a more natural state and will respond better to some of the engineering technology that we've developed. In the watersheds with 5 to 10% impervious, we begin to see the habitat impacts. And so what we tell the managers is, these areas you're going to have to limit harvest more, because you're getting these additional losses from habitat. And you may try stocking to compensate for some of those losses, and and stock in the years where you're going to get a good return for those. So it's really knowing how the populations respond. And then and for the land manager side, we're suggesting conserve these areas and do rehabilitation of your watershed where it's feasible. And then when you get past the 10% impervious point, from a fisheries management perspective, our options become very limited. In the Severn River case, where we have a trophy fishery, we were faced with the decision: do we open it or do we keep it shut? There's no natural reproduction going on there, so keeping it shut is not going to help the population. So the decision was, there's a residual fishery there, there's a trophy fishery, we opened it, the fishermen can enjoy it, and then if it happens to repopulate on a high flow year, then great, but naturally it's not going to repopulate itself. And that's been a controversial decision.
You're saying those fish come from another area
Yes.
to populate
Yes.
it. And
Yes.
for some reason they like that area in the Severn. So.
Yeah. And then from the landscape side, what we're saying is conserve what you have left and do re-engineering. Now, these areas that are over 10%, a lot of people would say, why would you want to re-engineer and why would you want to spend money there? And our take on it from a fisheries point of view is stream restoration in these areas can help with nutrient and sediment reduction to meet the TMDL for the bay. So we would not say don't do any work there, but we would say understand that that work is not going to probably rehabilitate local habitat, but it does have an effect on the larger scale bay.
And how good a sales is that?
Well,
sounds like people would say, well, I want to put my money where I can get my fish to come back if I've got a limited amount of money.
Mm-hmm.
So,
No, I want to put my money where my houses would go.
well, if you're talking just the fish study that they're talking about.
well, fish have very little voice in a lot of these decisions.
I know. I'm just
But
looking at.
That's why, and part of it, we own part of that because, we've been 8 years we've only been doing this for 8 years, and we've only been communicating really for the last 2. And so we've got a lot of work to do to catch up with some of the other conservation initiatives. But it's being received well, and we've been working with the Bay program, and they're really embracing this, and we're working with the fisheries group at the Bay program to try to take this to a broader regional scale and really develop planning tools and things like that can help communicate this, but also get it into the hands of the folks that make the decisions. So, and these are the kind of tools that we're making available to the land planners. One comment I hear constantly when I present this map is, you want us to protect the entire eastern shore? And my response is yes. But we're realistic, and I'm not saying, when we present these maps, it's, we want you to understand that you're planning development in a critical habitat. And so these are the things that we know will cause a fisheries impact. And so if fisheries is valuable to you, then you need to consider that when you're developing your comp plan. That's the way we're communicating this.
So you're mentioning the land planners, and I was wondering who you were referring to when you were saying that, and then you're saying you're presenting it to them. Does that mean you're presenting it to our county land planners?
The planning offices, we have, there's a broader tool. This is a part of a broader tool called Greenprint.
Okay, right.
And we've had, November, December timeframe, we had regional meetings where we rolled out Greenprint to everyone. We invited folks. We went to different regions, invited the planners. They came in, they saw this tool. Charles County has this tool. They have the Greenprint tool. I'm pretty sure they do. They've been very receptive. They've been a more receptive county to having us come in and work with them in the planning office. You know, when they were first developing their comp plan, they invited us down, and we spent a long time with them explaining the conservation priorities for Charles County. And then out of that came the Mattawoman ecosystem-based management document. We presented that document to the county council, or the commissioners. So they are aware of our conservation priorities in Charles County. You know, and the planning staff has been very receptive, and I think has really worked hard to get that information in.
What was the
plan.
name of that Mattawoman ecosystem?
Ecosystem-based management. There's a link to it on our website.
Thank you.
I can make this information a lot more available too. If you don't want to dig down through the website, if you just give me an idea of what you want, I can send it to Jerry and he can send it out. You know, but.
Margaret, when you say you decided you had to be more aggressive, does that mean that you decided to develop a habitat program 8 years ago? So you're going to be more aggressive. Does that mean you're diligently reviewing all the applications for Section 10404 permits from the Corps of Engineers and state permits for development?
It means we have an environmental review group that does that. They're aware of our priorities as well, and they're very diligent to look into our concerns when they do comments. When we say we're becoming more aggressive, we're looking at developing a way to not just get the tools in the hands of the users, but also a greater understanding of the importance of these tools and what it will mean. You know, our approach is an ecosystem-based management approach. And ecosystem-based management really works at educating everyone on, you know, what decisions, what are the consequences of decisions. And that's our hope, is that we can get not just the planners, but the politicians and the citizen groups all understanding, because the goal of ecosystem-based management is to educate and then hold people accountable for the decisions that they do make. So I know it's naive, but I mean, you know, we're fisheries managers. Our only authority is over managing stocks. I mean, we are at the mercy of land planners and, you know, even water quality managers and regulators. So it's going to evolve as we go along.